Hi, this is Mona. I'm presenting my final project in fraud prevention. Global fraud losses reached 21.8 billion in 2015, according to Nielsen report. About every 12 cents per $1 were stolen in US during the same year. In my project, I will train feed-forward neural network implemented in TensorFlow for predicting credit card fraud transaction. The data has been provided on Kaggle website. It contains credit card transaction that has been made in September 2013 by European cardholders. The dataset contains 31 columns. Okay, as I explained, this data contains credit card transaction has been made in September 2013 by European card holders. This dataset contains 2 days of where there are 492 frauds and 284 normal transactions. The dataset is highly unbalanced and skewed. The dataset contains 31 columns, which is numerical results of PCA transformation. Due to confidentiality issue, we don't have any information regarding the background of the features. There are 3 features that has not been transformed: time, amount, and class, which I explain more about them. Or I can say time is the time between each transaction and first transaction in the model, which I didn't use in my model. I don't think it explain anything about the characteristic of the transaction. And amount is the amount of transaction. Class is explained if the transaction is fraud or normal. The software that I've used in this project: Python programming language, Jupyter Notebook, and Anaconda. Anaconda is free and open source distribution for the Python programming language for data science and machine learning related application that aim to simplify package management and deployment. Jupyter Notebook is open source web application that contains live code, and TensorFlow is open source software library for high performance numerical computation. It originally developed by researchers and engineers from Google Brain team within Google's AI organizations. It comes with a strong support for machine learning and deep learning. I also use pandas and matplotlib, numpy for my data wrangling or data cleaning. And the hardware, I work with MacBook Pro with a 16 gigabyte memory. Here is overview of steps. First, I installed TensorFlow, implementing data engineering, data cleaning, data manipulation in pandas, separate test and train data, apply undersampling technique for normal data to balance it with fraud data, create a feed-forward neural network with one input layer, one output layer, and 2 hidden layers, which the output of one layer is the input of the next layer. Train the model and calculate train and test accuracy and visualization of the results and conclusion. Let me go through notebook to explain what we did. Okay, I first import the packages that I need to use, read the data. As you can see, I have this data has 31 columns and 284 800 or 7,000 rows, and I plot the distribution of the class, which almost 99% of it is normal distribution and 0.17% is fraud distribution. we don't have, there is not any missing value in this data set, which makes it easy to work with. Here I created another column for normal transaction and set the class to fraud transaction. Amount is the amount of transactions, and I normalize this column. Drop time color because it doesn't explain any characteristic of the transaction. And here I undersample the normal data to be balanced with fraud data. Now, 80% of, I train on 80% of my data and test on other 20% of the data. Oh no, here I did, okay, I transform, here we transform both train data. I create label and features data for both training and testing data set and transform those to matrix, or which I know matrix is kind of tensor. Here I set learning rate to 0.01 and batch size is 100. Create X, which is my feature tensor and Y is my label tensor. I create two placeholder for my label and features. As I explained, this model, here I created my model. This model has 4 layers, one input layer, and in each layer I define weights and biases. Weights are normal, and normal distribution with randomly normal weights with a standard deviation of 1, and bias variable is 0, set to 0, initiate with 0, and I use sigmoid activation function and dropout method for preventing overfitting in each layer. So first layer is input layer, second layer and third layer are my hidden layers, and here is my output layer with softmax. I chose softmax cross entropy as the cost function. I use L2 loss, L2 regularization. I implemented L2 regularization to prevent overfitting or add some penalty to my cost function. And I use Adam optimizer, with which I explained my learning rate was 0.01, and optimize my model and calculate the accuracy of the model. Here I train the model with both training data. I train the model with training data and test the model with the test data in 2000 steps, and the batch size is 100. And here I created the batch sizes of 100 for each step. I ran the model. I don't run the model right now because it takes time. So I ran the model and try to print test accuracy and training accuracy for each steps every 50 steps. And here is the plot. Here's a plot that you can see, and test accuracy in red and training accuracy in blue. As you can see, it is a very good model if we consider accuracy as an evaluation metrics. And final model accuracy is 93, almost 94%. And I plot loss function. As you can see, loss function is decreasing, but still 40% loss, almost 40% cost function is high, I believe. And what I've learned, okay, I fit for fully, I created 4 fully connected layer, and here is the model and conclusion and lesson learned. I can say while this model can detect fraudulent transactions with 92% accuracy, the cost value is still relatively high, and it is about 40%. So I should be concerned about this if if I accepted accuracy as one of the evaluation metrics. Before applying undersampling and L2 regularization, the model was overfit. And after applying the L2 regularization and before undersampling, my accuracy was 100% because the data was very skewed, and it was more than 99% of the data was normal distribution, normal transaction. Due to nature of fraud data, I believe unsupervised model may be better in clustering fraud and normal transactions. Yeah, I think if I want to go further, I will use autoencoder or neural network to cluster this data and predicting any transaction, cluster for any transaction that has been occurred. Even if I want to do classification, I would try other simpler machine learning technique like a random forest for classification. And for further experiment, I will use other metrics of accuracy for my model evaluation like recall and precision value. And here are my references and